Okay, I think I'm ready. I haven't been streaming in a long time. I wasn't even sure I could remember how to do it, but hopefully everything works out. Okay, maybe let's start with, yeah, okay, so um, what's my goal for today? Um, so I've been working on a pretty printing library. Um, and basically today what I'm doing is going over the introduction tutorial I have written for it so that I can like get a sense if it actually makes sense, if it's actually useful, so I can publish the library and have some peace of mind. Um, so first things first, why pretty printing? Um, I mean, it's if you ever find yourself in the situation where you have some kind of structured data, so for example, JSON, XML, or even the syntax tree of a programming language, sometimes not, well, usually you need to print it, but oh yeah, hi Ben. If you end up printing it like the simple, the quick and dirty way, usually it's going to look horrible. And printing something that looks good is usually very difficult when you have structured data because you have to keep track of a lot of things, for example, indentation. So, as an example, if I have a JSON, I can, of course, print it on a single line, but it's going to be unreadable if it's a quite long JSON. So I want to print it on multiple lines. The problem is if I'm printing up in multiple lines, I have to keep track of the indentation of each piece. I want to keep the fields of an object more indented, and themselves they may have objects as their value, so it has to keep going, keep the nesting increasing, etc. And usually it's quite hard. I've tried writing one by hand, it was super painful, and that's why I ended up doing this library. Also, I was inspired by the Gleam compiler. Yeah, I was working on a PR on the Gleam compiler. I saw the pretty printer and I said, well, I could try to port that in Gleam. Um, okay, so um, what are we going to do? We are going to be pretty printing a list of strings because it's the simplest data structure I could think of. And I think it's still complex enough to get a um, nice tutorial and see most of the package API. So how do we want to print our lists? Basically, what I'm doing is recreating the Gleam Pretty Printer. So if you have a list and wait, I can call it const list. Um, a list of strings, for example. Ooh, okay. Um, you want it, if the list is short enough, you want it to look like this. So you want it to be on a single line. However, when the list gets quite long, so let me try and reach the limit. Okay, wait, I don't want that. Okay, Gleam is quite smarter than me, but what I actually want is something that looks like this. So if the list is too long to be on a single line, we want to split it on multiple lines with an item for each line. So here we have the first, second, and third one. We want a trailing comma to be after the last element, so not like this, but like this. And that's it. So how can we do that? Um, so in this tutorial, I'm going to like work through some implementations, starting from the simple ones and then building up to something that is actually pretty printing the list. Um, so first things first, we need a function to pretty print a list. So let's try to write the types. After we have a type signature, we can try to start and work out the implementation. So we want to pretty print a list. Uh, its input is a list of strings, and it returns, and here we have the first bit that may be new to you if you don't know anything about pretty printing and pretty printing libraries. Um, so we are not returning simply a string. Basically, if we wanted to pretty print a list, we have a list of strings and we return the pretty printed string. But um, again, we don't want to do that by hand ourselves because that gets quite complicated easily. So we're going to take advantage of, in this case, my package, the Gleam package, and we are going to return this particular data structure, the document data structure, and wait, pub function, okay, and uh, here we are. The document data structure. So, what is a document? A document is basically something that the Gleam library, the Gleam package, can pretty print. So, as long as we can turn something into a document, then the library will pretty print it for us automatically. And the pretty printer can be quite smart, so it can split the document if it exceeds the line, the maximum width of the line. And so yeah, that's basically the catch with using this library. You have to turn something into a document, and then it's the library that is actually going to turn these documents into strings or string builders, whatever we need. So we now need something to create documents, and the library provides some basic constructors and combinators, so you can combine simple documents together to get more complex documents, and you can also like build documents from strings, for example, and basic types. So we can start with, for example, creating a document from strings. So in order to do that, we can use the fromString method. That shouldn't be too surprising. And for example, this creates a document that when it's pretty printed is printed as foo. So let's update our main function so that we can actually see how things get pretty printed. So we're going to create an example list, which is Gleam is fun. I think something we can all agree on. And then we are going to pretty print it. So pretty print list. Oh wait, I can just pipe into it. Okay, and now that we have a document, how can we turn a document into a string? We can use the function toString from the library. ToString takes as its first argument the document we want to pretty print, and its second argument is the maximum width of the string we are going to pretty print, and that basically serves as a kind of hint indication to the pretty printer to know when it can split documents. Because the pretty printer is always trying to fit a document into the maximum width, and if it cannot fit the document into this line, it is going to split it according to some rules we are going to see later. So for now, let's just give it a lot of space. So we are saying pretty print this document and use as a maximum width 80. So the string we are going to pretty print is going to be at most, almost always, at most 80 characters long. Okay, and of course we have to actually print it. So print line. Okay. Yeah, and here we have it, foo. Because a document that is created with fromString is always pretty printed as is. We keep the string unchanged, so even if we have like a really long string, the pretty printer isn't going to split it. That's why I said the maximum width is like a hint to the pretty printer, because the pretty printer tries to keep everything under the, for example, here 80 characters limit, but sometimes it cannot. For example, if we give it a really long list, a really long string, wait, what did I do? Okay, like this, that is way over 80 characters, but as you can see, the pretty printer isn't splitting it. And that's good actually, because it's going to exceed the line limit, but it's not going to produce some unexpected results where for example, our code we wanted to pretty print gets split on unexpected points. The pretty printer always splits our documents where we say it can split the document. So it's not going to do strange things where it splits strings we provide it. Okay, so we can create a string from a document, so we can turn the items of this list into documents, and that should be like a lot of the work we actually need to do. So let's write a simple function, list item to doc, which is going to convert an item into a document. So we are going to use doc to string from string and give it the item. Then what we are going to do is we are mapping over the list. So list.map list doc, and then we have to do something else. Okay, we have to import the list module. Great. One thing, we want list items to be wrapped by quotes, double quotes. So we're going to do that here with simple string concatenation. And here we have it. Okay, so right now we can turn the list items into documents and we get a list of documents here. But we need a way to turn a list of documents into a single document. So we want to join documents together in order to get a single document that can then be pretty printed. Just my list map. Yeah, you're right. Doc from string. Yeah, I could just doc from string, but I want like the double quotes to be here. Because if you are simply turning a string into a document, then in the pretty printed list, there's not going to be the double quotes surrounding the strings. So I'm just keeping it as a separate function because otherwise it could be quite long. So what are we going to do now? Yeah, we need a way to join documents together. So this is a list of documents. We can see the error here. It says, I expected a document, but I found a list of documents. In order to join a list of documents together, we can use a function from the Gleam library, and it is doc.concat. Concat basically is going to take a list of documents, join those together as a single document, and that is the result of concat. And yeah, so we are already a long way in. So let's see how things look. Yeah, it's not like a lot list looking, but I don't think I think that should be, I think you can see that. Yeah. The list module name? No, it doesn't, because module names are on a separate, how do you call it, namespace as value names. So the Gleam compiler can tell the difference between the list module and the list argument. I agree it's not the best, maybe, because it can be quite confusing to see list as the name of a module and list as the name of an argument. So I'm going to change that. Strings and strings. That should be better. Okay. So, okay, as you can see, here we have now three pretty printed strings, but it's not quite list looking. We need to add the brackets and the commas separating everything. So let's do that. And we can just take advantage of the list module. So we can, for example, to add the commas between each element, we can use dot intersperse. So intersperse with, and here we have to say we want to add a comma and a space between each of the elements of the list. So we are going to do a dot from string, which is comma and space. And as you can see, now we have something that is quite better. So we have Gleam, comma is comma fun. And this is getting closer to what we wanted. We just need to add the open and closed brackets, and then we are done. So list dot append to append the closing bracket, so dot from string, and here we have it. And we have to prepend the opening bracket. Okay, and here we have it. Um, as you can see, the list is pretty printed, but there's a catch here, because we are going to be disappointed when we when we actually reduce the line width and try to fit the list on something that is smaller. So if it definitely doesn't fit on a 10 characters line, so it should, like, we want it to be split on multiple lines. But as you can see, the list is exactly the same. So the pretty printer isn't splitting the list. So why does that happen? Because again, when we concatenate documents together with concat, for example, uh, the pretty printer still prints them exactly as they are. So it's going to be the first document, and then it's joined with the second document, third document, etc. But it's not going to insert any new lines or breaks. For example, if you want it to be on a line that is smaller than the actual width of the document, of the final document. Um, because we haven't told the pretty printer to explicitly that he is explicitly allowed to break the document there. So how can we do that? Because right now the list is pretty, but it only like outputs a list that looks like this, and we could have done that with just string concatenation. So we are just concatenating strings, but in a more convoluted and difficult way using another library, a third-party dependency. So that's not good. We want something out of this pretty printer. So how can we tell it to actually split a list? So in order to do that, we have two basic building blocks, and those are the doc.space and doc.group. So doc.space and doc.group, and we're going to see each one of those. So first of all, what is a space? A space is just a special document which gets printed as a white space, so as a single white space, but it also acts as a possible breaking point for the pretty printer. So whenever the pretty printer finds a doc.space, it knows it is allowed to actually break the document there if it's longer than the line width. Um, and document.group is a way to tell the pretty printer it is allowed to split the spaces inside a given document. So doc.group takes as input a single document, so we can, for example, give the document we got with concatenating all the list items to document.group. And now the pretty printer knows that whenever it finds a space inside inside this document, then it is allowed to split it. So we can start inserting spaces, and we'll see that the pretty printer actually splits them. So let's do that. We have to add spaces. So we can do that, for example, here. We are going to intersperse not comma followed by the hard-coded space, but our document space. So we have to concat those together. Um, we can do it like this. So let comma equals dot concat from string comma and dot space. So as you can see, we are not adding manually the space because that would be always rendered as a single white space. The pretty printer isn't allowed to break that. However, if we use doc.space, so the library, a document that defines a special kind of space, it can get printed as a single white space, but if the pretty printer decides to do so, it can also split the space and turn it into a new line. So that's exactly what we want. We're going to intersperse the document with comma, and we are good to go, I think. Yeah, and as you can see here, wait, first let me increase the line width. As you can see, if the document can fit on a single line, the pretty printer is going to render each space as a single white space, as we would expect. However, if the document doesn't fit on a single line, each space is going to be rendered as a new line. So right now we have something that is looking better. It's more like what we wanted. We just need a way to uh, indent things. So we want is, Gleam, and font to be indented. Also, Gleam needs to be on a new line on its own. We don't want it to be on the same line as the open bracket. And we want a trailing comma here. So we need to find a way to put a comma here as well. So first things first, I think we can make our code a little bit simpler using some utility functions from the library. So we have a function that is called join in the Gleam in the doc module. So doc.join basically is the same as interspersing and then concatenating. So it's doing all the work for us. And then we can use the doc.prepend and append, uh, which does exactly what you might expect. So it prepends a document to another one, or it appends a document to another one. So this is going to put brackets before and after the document. We obtain by joining every item, separating it with a comma. And comma, again, is defined as a single comma character and a special kind of space that the pretty printer can break. Okay, this is looking good. Again, I think maybe I'm biased because I've been writing pretty printers for a couple of days and now I kind of got used to it, but I also kind of like how it looks. So we are going to say turn each string into a document, we join it with a comma, we prepend an open bracket, we append a closing bracket, and we group everything together. I think that that's quite nice and also already an improvement from like manually concatenating strings, with a recursive function, etc. So it's already, I think, a nice API. But again, I might be biased, so I'm not the best judge for that. Okay, so it's looking good. Now, oh, I'm happy. It seems easy to understand. Yeah, I'm really happy you're saying that. Um, So we need to add, first of all, a space that can be broken even after the opening bracket because we want it to be like the Gleam word, we want it to be on a new line. So we can do that quite easily. So we're going to define a left bracket. Wait, yeah, left bracket, which is again, concat obtained by concatenating the open bracket. So left bracket um, with again a dot space that the pretty printer can break. So as you can see now, Gleam goes on a new line because the pretty printer decided that document needs to be broken because it doesn't fit on a line of 10 characters. So it goes on a new line for each of the spaces. And then we have the right bracket, which is dot concat, and exactly the same, but swapped. So we have the closing bracket and the space before that, and we are putting it here, bracket. Okay, so this is almost done. So as you can see, it wasn't too hard to do. Um, and another thing I want to point out, as you can see, we say we want the pretty printed list to fit on a 10 character line. And let me add a little guide that can show us the actual limit. So limit is 10, and we are going to string dot repeat, I think, yeah, 10 times and print like that. And here we're going to use limit and limit. Import the string module. String. Okay, so we can see the 10 character limit. Um, as you can see, like the pretty printer, how does pretty printing work? Okay, we can try to explain that now because we have already introduced kind of a bit of builders. So we have group, we have from string, concat, etc. So and space also, which is super important in order to break things on new lines. So how does the pretty printing process work? Basically, the pretty printer is going to inspect our document data structure, and what it's trying to do whenever it runs into a group is it's trying to print the group on a single line. So it's basically it tries to render it on a single line. So for example, here it tries to output the list, keeping everything on a single line. So displaying spaces as single white spaces, etc. Uh, and then it can see, does it fit on a single line or it doesn't fit? So if it does fit, that's it. That's the result we're going to get. So for example, if we increase the line limit, and wait, maybe 80 is a bit much, 30? Yeah. So as you can see, the list fits on a 30 line, 30 characters line. So the pretty printer simply outputs that, and that's easy. Uh, so what's difficult for the pretty printer is, I mean, not difficult, but the special case is when the string doesn't actually fit on a single line. So what would happen in that case? The pretty printer tries to make it fit on, tries to output it on a single line, but it doesn't fit. So it starts breaking every space inside the outermost group into new lines. Um, so as you can see, every single space that was in the group of the list was broken into a new line. Um, for example, if it didn't break the last space, it would have fit on a single line. So if it were like this, let me copy and paste it. If it were like this, it would still fit on a single line, as you can see, because this is not that more than 10 characters long. But the problem is that, I mean, not the problem, the behavior of the pretty printer is that whenever it decides that a group doesn't fit on a single line, every single space inside that group gets broken. So it's an all or nothing. Um, uh, yeah, and that's basically the working of the pretty printing process. You may wonder what happens if we have groups inside groups or nested things. Um, that's not too complicated. So maybe this is not the best example because we're not going to have more groups one inside the other. I can show you maybe a more complex example, but I think for now that's more than enough. But basically, whenever it decides to break a group, and we have inner groups, so other groups nested inside, um, what the pretty printer is going to do is trying to display every single one of the inner groups on a single line. So it decides on a per uh, group per group. That's a tongue twister. On a group by group basis, uh, whenever it whether it needs to split it or not. But if it decides to split a group, every space inside it is going to be split. Maybe we can also update this example to show it. I think it's not going to be too hard. So we can try to do it like this. So after joining everything with a comma, this is the body of the string and then the list, and then we add the brackets. What if we put this inside another group? So this can, this way, maybe, and we have to increase the line just enough for it to be, yeah, that's it. So that's the sweet spot. As you can see, uh, since we have two different groups, we have an inner one, which contains the body of the list, and then we have an outer one, which has the brackets and the body of the list. So when it runs into the outermost group, it tries to output it on a single line of 24 characters, and it doesn't fit, so it decides to break it. So every single space inside this group gets broken. But the spaces inside this group are these one, the one following and preceding the open and closed brackets. Um, and then it runs into another inner group, but it decides whether it it needs to split the inner group or not based if on its length. So it's not automatic. So if the outer group is split, it's not necessarily going to split inner groups. Um, so, for example, here the inner group still fits on a 24 line, so it's not going to be split. But if we make it even shorter, so if we make these 15 characters long, it's going to split even the inner group, because even by splitting the outer group and going on a new line with this space and this space, it's not going to fit this one on a single line. So it splits everything. But right now we don't need that level of granularity. It's enough to have one single outer group, because everything gets split or not. We don't want to end up in the situation where at the 24 character limit, this goes on a single line and this goes on their own lines. That's perfectly reasonable to want that, but for this example, I said I was going to put every element on a new line if it gets split. Okay, so let's get back to working with our list. So now we added these spaces, and it's perfect when the list doesn't fit on a single line because everything gets split. Let's not care about um, the most pretty printer work this way with spaces and groups. Uh, I have no idea. So I have no idea. The Gleam pretty printer, yeah, it works like that. I've seen the implementation. My implementation is basically a one by one porting of the Rust code in Gleam, um, with less features. So yeah, I'm pretty sure the Gleam pretty printer works like that. There's these kind of pretty printers. I think they're called algebraic pretty printers, which they, as far as I can see, kind of all work the same way. So you have this concept of groups, this concept of spaces that can be broken, groups can contain other groups, etc. And yeah, that's basically the gist of every algebraic pretty printer, as far as I can tell. I have seen some pretty printers in Haskell, for example. Um, oh yeah, you're going to use that to print Gleam. That's great. I'm really happy that someone is going to use this library. Uh, um, yeah, so let's keep going because we have fixed this. So items go on single lines, but we have introduced a new problem. If the list is on a single line, we have these spaces, but we don't want those. When the list is on a single line, we don't want this white space to be displayed here. But with the building blocks we have right now, we kind of cannot do that because dot space is always rendered as a white space when it's not split on new lines. So we need some kind of new builder for documents that can get displayed differently based on whether they're broken or not. And also we have one last problem. Wait, no, two last problems. So things are not indented. We want these to be indented. And also we want a trailing comma here. Let's start with the simple one, so the indentation. Indenting is super easy with these kind of pretty printers because there is this function, which is doc.nest, which does what you might expect. So when you have a nest, every space that is broken by the pretty printer is also indented by the nesting we say it has to be indented by. So doc.nest by 2, for example, here. So what this is going to do is every space that comes before this nest is going to be indented by 2 spaces if the pretty printer decides to break it. So if we put it here, you can see that every space before this nest, so inside this document basically, is going to be indented by 2 spaces, which is great for the list items, not so great for the space that comes before the closing bracket. We don't want this to be indented. We want this to be on the same indentation level as the open bracket. But it's super easy to fix. We just need to move up the nest by a level. So it's going to include every space here, but not the space that comes with the right bracket. So yeah, fixed. Super easy. Um, And that's it. We have indented things. So that's really nice. Another nice thing that I love about these kind of pretty printers is that they can automatically manage the nesting level of things. So if we have multiple nesting, for example, right now I'm just going to use two nesting, one followed by the other, but oh, hi Rob. Then I can finally have consistent indentation in the helpless for games. Oh yeah, that would be great. I would love for you to use that. So if you have multiple nests, for example, the nesting level is going to sum up. So it's going to be indented by three spaces here, which is super useful when you have, for example, recursive data structures, for example, like JSON, which needs for which you need the indentation level to keep growing. So I'm going to show you the JSON pretty printer after working through the tutorial, and I'll show you how that works. So yeah, that's it. We have indented things, so that's great. We just need to fix two things. Uh, we want a trailing comma to be here, and we want spaces to not be here when the list is on a single line. So how can we do that? These are two different problems we can solve with the same document constructor, which is the last constructor you're going to need, and then we're done with the library API. That's basically it. So it's all you need to print nice looking documents. So the last constructor is break, um, which is doc.break. Doc.break takes as input two arguments, which are two strings. And what are those arguments? So I'm going to, for example, say this is not broken and broken. So the first argument is a string that is going to be displayed. So what does the pretty printer do when it runs into a break document? So string, etc. How does the pretty printer handle break documents? Basically, it's always trying to display a break document as its first argument. So normally every break document gets displayed as its first string. However, break documents act a lot like spaces. They are points that the pretty printer can decide to break on. So if a group, for example, exceeds the line limit, the pretty printer is going to break every single break document inside that group, much like with spaces, into new lines, and it's going to render the break as its second argument before inserting the new line. So this may sound confusing if I'm explaining it to you, but I think that code can be quite better at understanding it. So let me come up with a simple example. We're going to have a list of strings. So Gleam is fun again. Fun. We are turning this into a list of documents. So list.map doc.punt from string. And then we're going to join those together with a break because I want to show you how that works. So join with break. And here I'm going to use this and this. And then we are going to pretty print it. So, wait, I need to say that this is a group, so the pretty printer knows that it is allowed to split break documents inside it, so group, and then we can pretty print it. To string, and we're saying on limit and print line. Okay, so as you can see, the pretty printer tries to print it. I'm moving this up. Okay, so the pretty printer tries to print the document on a single line by rendering every single break as its first argument. If it fits, that's great. That's the string we're going to get. So that's it. Gleam is fun. And as you can see, every break document is rendered as a single point. We can also make it longer. That's great. However, if the document doesn't fit on a single line by using break document's first argument, the pretty printer is going to split it on new lines. So it's going to insert a new line uh, after every single break document that gets displayed as its second argument. So if we reduce the limit a lot, for example, 10, as you can see now, the pretty printer decided to split it because it doesn't fit on a 10 line, a 10 character line. And every document, every break document is rendered as its second argument before adding the new line. Um, so yeah, that's basically it. We break is really useful if we need to like conditionally render something whether the document is split or not, and that's exactly what we need in our example. But before fixing our example, um, on the error printing in this Snagit. Ooh, I would love to try that. I have to look into Snag because I never got like around at using it on a project. So that may be like a nice test for the library. Yeah, I'm going to do that. Um, what was I saying? Oh yeah. So doc.space, actually, I lied to you, is just a constant declaration for a break. Because if we define a break like this, that space equals doc.break, um, that's exactly the definition the library is using for space. Uh, because if the document fits on a single line, it gets rendered as a single white space. If it doesn't fit on a single line, it doesn't get rendered as anything, but the pretty printer is going to add new lines. So space is actually defined in terms of break. Break is the more general construct, and space is simply a call to break. But since space is quite is used almost everywhere, I just have this constant that can come in handy. For example, if you're writing a lot of these things, because it would be tedious to always write this or redefine your own space a lot of times. Okay, so that's it, and we can use break to fix our library. I hope you can see how it can be used to fix the library, but I'm going to show it right now. And it's a really small change. We just need to change the behavior of these spaces. Because here, for example, after the first opening bracket, what we want to do is to not display the space uh, if it's not broken. So we have to use break. And if the document doesn't get broken on new lines, we don't want to display anything. We don't want a space to be there. If it gets broken on a new line, we don't want to display anything as well. We are just happy with the pretty printer inserting a new line. We don't want to add anything before that new line. So that's it. A doc.break that takes two empty strings. And as you can see, the space is gone. But again, breaks act as a possible breaking point for the pretty printer. So if we decrease the line limit again, uh, as you can see, the pretty printer still breaks on that document. And let's increase the space again. Here as well, we want the space to not be there. So, oh wait, just a little thing. Um, doc.break. Oh yeah, it could be like that, but I'm going to show you another thing, which is soft break, which is another definition from the library, which is exactly the break with two empty strings. Because again, it's kind of common to want to insert these kind of breaking points that never get rendered as anything, but just act as possible breaking points. So again, this is just a shorthand for break with two empty strings. And I like to keep those two separate. So you could, of course, say doc.break with two uh, open brackets. But I think it can get quite harder to read, especially if you're not too familiar with the library, because you have to know that break is this is the first argument, this is the second one. So if you're not super concerned about the size of your document growing, you can just use two documents and that's great. And also that splits things quite nicely. So you have the open bracket and then you have the soft break, the breaking point for the pretty printer. So you keep those two separate, and to me it's easier to read, to understand what I want to do there. But doc.break with two open brackets is perfect as well. Um, and here we want to do this. So if again, if it gets printed on a single line, we don't want anything to be displayed. If it gets printed on a new line, uh, if it doesn't, yeah, we can, for example, now use the soft break, and we're going to change that. So right now the string looks perfect on a single line. Let's see how it looks on a new line. Um, Yeah, and that's great as well. So it breaks where we want it to. The missing piece is the trailing comma, but that's exactly what break can help us solve. So instead of using a soft break here, we're going to do this. If the document is on a single line, display nothing. If the document goes on a new line and is broken here, before inserting the new line, just insert a comma. And here we have it, the nice looking trailing comma. So this is the list pretty printer. As you can see, it's quite compact. It didn't grew that much, even though we added these complicated things like displaying the trailing comma, breaking, nesting, etc. Everything just remained quite small and easy to read and understand. Um, I can, if you want, you can try like a manual approach. So trying to do this by hand without using a pretty printing library. I think that gets quite hard, quite tedious and error prone. But to me, this is like really nice, quite readable. So I'm pretty happy about the result here. And yeah, that's it. That's the pretty printing library. You know almost everything about the library API right now. There's just some more utility functions. For example, you have uh, prepend docs if you want, which is just a shorthand for a prepend, and here it takes a list of documents, and it's just going to concat these and then prepending. So it's just some shorthands that I found to be useful, but I may remove those or add them, who knows. So yeah, that's it. And let me show maybe. Oh yeah, I mean it's super hard. For me, like the most difficult thing of doing that by hand is keeping track of indentation and making everything look nice. That is super hard for me. So I'm really happy that the Pretty Printer can take care of that, and I just have to say, yeah, nest this by two, and that's it. So that's the full Pretty Printer for lists. I'm going to show you, if you want, the JSON Pretty Printer, which is again quite small. That was surprising to me. I thought it would be way messier, but it's actually quite nice. So here we have the JSON type. Wait, let me change um, the modules so I can show you the output. Yeah, that's it. Maybe I can make this bigger. And yep, I think okay, good to go. Um, so here we have a JSON definition, so string, number, bool, null, array, objects, etc. And here we have an example object. Um, it would be cool to use Haley's parsing library, because I remember Haley's library to have a like a um, JSON parsing example. So it would be cool if I just used that and then didn't build this in Gleam but parse a string. But yeah, I couldn't be bothered to do that for now. This is a big object, as you can see, and it has string fields, it has numbers, booleans, arrays, nested objects, etc. What I wanted to do was getting a pretty printer that always tried to fit lists and objects on a single line. So if it can fit on a single line, it is kept on a single line. But if it needs to be split on multiple lines, then it just splits it. Um, so as you can see here, I have multiple line widths. So here we have 30, nothing can fit on a single line, so everything is split, as you can see. Um, we have a 50 line width, and as you can see here, the Pretty Printer is being smarter because now it can keep these objects on a single line because they are small enough to fit on a single line. Here it had to split those. And if we increase the width even more, it's also going to keep the array on a single line, for example. If we gave it a really huge max width, it's also going to keep the whole object on a single line. But yeah, for this kind of width, I think it's really nice looking, and it's not splitting everything where it's still readable on a single line. So that's it. And let me show you how that works. So we have this function, the JSON to doc, which is like the core of turning a JSON into a document. So if we run into a JSON string, just turn that into a string. If we want to display a number, so it's going to create a document from the string representation of that floating point number. I didn't try to be smart here. I could try, for example, to hide the decimal point if it's always 0. I don't think that was really worth the extra effort, so I just kept it like this. Booleans, quite easy. We turn the boolean to a string. Here, Gleam uses the uppercase, so since JSON uses lowercase true false, you turn it to a lowercase string and then turn that into a document. Null is just null, easy peasy. And then we have arrays and objects, and both can be pretty printed in a similar manner. So both arrays and objects, as you can see, that's really beautiful to me. Like it's almost exactly the same code. So first we turn everything into, for example, let's start with arrays. We turn each JSON object of the array into a document itself. So this is just some recursive calls. And then we are going to join those with a comma and then a space. Comma is just defined as the comma. So doc from string with the comma character. So those get joined together, and here I have another utility function for the pretty printing library, concat join, which is the same as doing doc.concat here and then joining. That's exactly the same, but that was a bit nicer to me, so concat join. Basically, it's going to use these documents as the separator to interleave between each of the documents of the original list. So between each of those documents, we're going to add a comma and a space that can be broken by the pretty printer, and we're going to parenthesize this, so adding parentheses before and after, and I'll show you the implementation of parenthesize later. And for objects, it's almost exactly the same, so we are going to turn each field into a document. We are joining those together with a comma and a breakable space, and then we're going to parenthesize those, so adding the open and closed brackets before and after. How do we turn a field into a document? That's not too hard. So we just get a field is a pair of a name and a JSON. So we turn the name into a string using the from string. We turn the JSON into a document using JSON to doc. And then we're going to concat everything together. So we are printing the name, a colon, so name, colon, a breakable, an unbreakable space, so it's just the string space. We don't want this to be broken by the pretty printer, so we are just going to use the string for the space. And then we're going to add the last document, concat everything together, and we're good to go here as well. As you can see, each single piece, maybe I'm going a bit too fast here, but I don't have much time left, I think. Yeah, it's almost an hour. Each single piece makes sense on its own, and then we can combine those together into more complex documents. But on their own, they're quite easy to understand. So here we have the name, the colon, an unbreakable space, and the value document. And how does parenthesize work? So basically, it's going to prepend to the document the open parentheses and a breakable space. It's going to nest that just like we did with the pretty printed lists I showed you earlier. And then it's going to append two more documents, a breakable space and the closing string. So this space is not going to be indented, and this is going to be indented. And we are grouping everything together because we want to say, hey, Pretty Printer, you can break the spaces that are here. So we have to say that this is a group if we want the Pretty Printer to actually break these spaces. And that's it. That's everything there is to pretty printing a JSON document. And as you can see here, we nest by two, but the nesting actually accumulates. So here, for example, we first start nesting by two because we had to break the object. But when we are rendering the characters field, for example, here it gets nested once again by two more spaces. So it's not nest this by two and it's all going to be nested by two spaces, but it's going to increase the nesting level by two spaces. So whenever we have another document that gets nested by two spaces, it's going to be four spaces, then six spaces, etc. So here, for example, the nesting keeps increasing up to six spaces. And yeah, that's it. Yeah, I think it's quite nice. Yeah, I mean, it's not too hard to read and pretty concise. So yeah, that's a nice thing. Also, here we do not have a difference with the lists we were pretty printing earlier. We do not have commas, the trailing comma, because JSON doesn't actually support that. I was surprised to discover that. I was sure it would support trailing commas, but it doesn't. So yeah, that's it. Um, yeah, I don't have any more examples, but you gave me some nice ideas, so I'm going to look into this Nug library, for example, and I see what I can get. So I still haven't published the library yet because I was going to keep working on the tutorial, which is basically what I told you right now with the pretty printed list example. But as you can see, everything you need to know about the library can be discovered through this example. So I think it's quite nice because it's not a complex data structure. You don't have to deal with JSONs, recursive things, etc. And it's also going to be so quite easy and you get an immediate result. Um, After completing that tutorial, I think I could publish it. I wanted to write another one on maybe that maybe focused more on nesting things and like having more than one nesting level because here I don't show that. But I think that for a first release, that is also pretty reasonable. So I think in maybe I could also do that today. Yeah, I could also publish it today. So Ben, you can start using it if you want. And yeah, if you ever end up using it, everyone who is going to find this video, I'm going to upload it also on YouTube. So everyone who finds this video and wants to start using the library, if you are confused or feel like there's something you still don't completely understand how that works, please reach out to me. I'm really happy when people reach out to me and ask things. So do that, please. Um, I usually hang around in the Gleam Discord server, so you can ping me there. Otherwise, you can find me, for example, on Twitter. I'm Giacomo underscore Cava. And yeah, so if you end up using the library, let me know because that will make me really happy. So when you publish it, if you're better than me, I've published with just the examples here. Yeah, I mean, I'm that's kind of a curse because I lose a lot of time like polishing things and I never get things done. So I mean, I hope people appreciate that, but it's really bad for me because I take a lot of time to do even the simplest things like writing a tutorial. I mean, I could also publish it now, but I have to read it at least 20 more times to make sure I didn't make any mistakes. Okay, so that's it. Thank you so much for everyone who followed this stream and see you next time. Who knows when it will be, maybe in another month. So see you. Bye bye.